So we've got an SMD impedance meter. This is the IM-SG Plus. This is a little meter that will single-handedly measure the impedance of the driver and tell you where the impedance is and at what frequency. So this is kind of neat. I don't know if you can zoom in on that, Steven, so they can see it. So this is connected to the speaker. It's using a 9-volt battery to power the speaker. See if I can get down here and get out of the way so you can still see it. In fact, let me try to turn this towards the camera a little bit more. So, and I'm going to get down because with the glare I can't see it. So we got this at its lowest frequency possible. Now this is a 4-ohm driver. So if we notice, at 9.1 hertz, it's got an impedance of 5.7 ohms. It will never go below the DC resistance. It will always be a little bit above the DC resistance. So we want to know what the resonant frequency of this driver is. So how do we do that? We start increasing the frequency, and notice what's happening to the impedance. It's going up. So let's keep pushing this up. I mean, we're already at 30 ohms at 26 hertz. So let's keep going. How high can we get this? 44.5. That's probably going to be pretty close, 30.5 hertz. And if you guys have your computers, you go online and look at the resonant frequency of that driver, guess what? It's 31 hertz. So that's where the impedance is the highest. That's the infinite baffle response, or just the impedance curve of the driver. As I go higher in frequency, there again, you see that impedance dropping as I go way above the resonant frequency. Kind of interesting. Basically what it's saying is at the resonant frequency, you have the highest impedance on the driver, but resonant frequency means the frequency to which something vibrates the easiest, so it takes less power to make that speaker move. So they kind of work together. They kind of, pretty much cancel each other out. So that was our impedance curve on the driver, and I'm going to, Steven, would you write this on the board up there? Because I might forget, it might be good information later. So write 31 hertz at 44 ohms. So now let's take this same exact setup, if I can get it to let go of the spring terminals. Alligator clips and spring terminals don't get along very well. So the next thing we're going to do, we're going to set the woofer aside since we've already measured that. We're going to go ahead and put this in a sealed enclosure. And here again, we're going to go down to where we get the highest impedance, which I said was somewhere around 60 hertz or so, 59, 60 hertz. So that's the frequency the speaker is going to move the easiest, and it's using the resonance of the speaker along with the resonance of the enclosure. That added together gives us a total resonant frequency of about 60 hertz. So kind of interesting on the sealed enclosure. So to find the tuning frequency on a sealed enclosure, you look for the highest impedance. So let's go to the vented enclosure now. All right, step around the side so I can get the terminals on this speaker. And like I said before, if you notice, we're doing this tuning with basically a 9-volt battery. We're not tuning this at maximum power output. We're just looking for the actual impedance curve of the driver. All right, so let's go back down to our minimum frequency. Ernie, there you go. Switch back to this one. Hopefully you guys can see these numbers. All right, 9.1 hertz, I'm at 5.6 ohms, and this is a vented enclosure. There is a side vent in this truck enclosure. It's still a 4-ohm driver, and we can tell that because we're above 4 ohms on the impedance. So let's start bringing this up in frequency, and let's see what the impedance does. All right, so we're up to 20 hertz. We're almost up to 12 ohms. Oh, uh-oh. Low battery voltage, that's not good. All right, so here again, at about, actually, our highest impedance is at 16 ohms on this enclosure. Let's turn this up to where I get to the lowest impedance. I can be right about there. So 5.4 ohms at 36 hertz. So that is the tuning frequency of this box. Being a small ported box fit behind the seat of a truck, it's tuned at a little bit higher frequency. And we can tell that because that's got the lowest impedance. And as we go up in frequency, we're going to get that second peak. Which we're over 20 ohms at 73 hertz. So once again, that's telling me that this box is underdamped. So it's got a lot less control in the driver at the lower frequencies because it's got a lower impedance at the low frequency. So pretty much follows exactly what we saw on the graphs.